So we're jumping back into what we left off yesterday when we had some technical difficulties at the end of class. And we just started talking about the difference quotient. So you may remember how to do the difference quotient back in algebra. But basically, this is finding the slope between 2 points. And so the points that we're finding the slope between were the point x, and then the y value we could write as f of x, and the value x plus h, and then we could write the y value of that as f of x plus h. So if you found the slope there, the denominator actually simplified, and we were just left with the h. So, the change of y, which we had this f of x plus h minus f of x all over the same y value you start in the numerator, you have to use that x value when you start in the denominator. So this x value, x plus h, minus this x value here. And so there's where our x's cancel in the denominator, giving us this difference quotient. So this difference quotient we're going to be seeing a little bit later. It's part of our definition of a derivative. So we might get there next week, but you need to be able to use this difference quotient. And so we started on an example yesterday, and I tried to pull one that could bring some other factors of algebra in here that you might not have remembered. So the example that we were doing was we were given that f of x was equal to function 1 over x. And it asked us to find the difference quotient. And so plugging this in, our f of x function is 1 over x. And if we looked at f of x plus h, we would plug in this x plus h, right? So if this had been like f of 2, we plug in 2 wherever we see an x. So don't get caught because it's an expression with variables in it. We're doing the exact same thing. We're plugging this x plus h in wherever we see an x in here. So that would give us back x plus h in the denominator. Let's change colors. And over that. So this is this f of x plus h piece. So let's write that there. So 1 all over x plus h minus, it tells us to subtract off our f of x function, but our f of x function is defined as 1 over x. So minus this 1 over x all over your h value. So unfortunately, I'm not familiar with that program. So this program, we're just trying it out, see if this works better than the other ones. Okay, so this isn't simplified down. We have a complex fraction. We have fractions within fractions, and we don't usually like that, and we want to simplify it. So there's a couple ways to simplify complex fractions. I personally like the way where you multiply by that fancy one. Multiply by the least common denominator of all the fractions within this main fraction. So if I look at this, I have this x plus h as a denominator, and I have this x as a denominator. So my LCD is equal to this x plus h, that quantity, so parentheses around the whole thing, times x. Okay, so a lot of times we use tools of mathematics to take something that's complicated to make it simplified. And sometimes that's just multiplying by this fancy one. And so we're going to multiply both the numerator and denominator by this x plus h, that quantity times x. all over x plus h, that quantity all times x. The whole point of that is so when we distribute, the terms that have the variables in there in the denominator will cancel out, or the denominators will cancel out. So we got to distribute this to each term or grouping in the numerator. And so when we do this, right, I'll write out the step for now, but normally I don't. This is 1 over x plus h times that quantity x plus h all times x. You can think of that over 1 if it helps you. Minus, then we have this 1 over x all times this x plus h times x. It helps you put that over 1. Divided by h all times x plus h times x. So notice up here in the numerator, this first grouping, we have both the x plus h's in common. Those cancel. And then over here, the second grouping in the numerator, we have an x in the denominator and an x in the numerator here. And the only reason why we can cancel those are because they're factors, there's multiplication in between. Usually, we do not want to distribute this piece down here in the denominator, and I'll show you why in a second. But once we've simplified, that first grouping, all we have left is this x minus those x's cancel. So be careful because there's parentheses around here. That negative has to be distributed to that whole quantity of x plus h. All over, so I'm just going to rewrite my denominator. H all times x plus h, doesn't matter order, all times x. And so when we distribute this negative sign inside the parentheses, we get x minus h all over, I'm just going to rewrite the order, hx times x plus h. Again, it doesn't matter. Almost there. So notice the numerator, you can cancel the x's, x minus x is 0, so we have a negative h all over h times x times the quantity x plus h. And again, we have common factor in the numerator and denominator, and so we can simplify a little further. We have an h in common, leaving us with just a negative 1 in the numerator all over x and x plus h. That's as far as we can take it. We technically could distribute that x in the denominator, but it's not going to help us to simplify any further or cancel anything. Okay, so that was the difference quotient of the function 1 over x.
Professor? So what was this question about?
Oh, sorry, so this was asking us to find the difference quotient. So let me go back on page.
Oh, the difference quotient.
So it was asking us to find the difference quotient of 1 over x. And the difference quotient is this function. Or this.
Okay. All right. And what did we talk about before? Like, is this the first topic we talked about?
This is, we started talking about average rate of change, and I'm going to talk about instantaneous rate of change, but I'll like review what we talked about yesterday.
Okay. Okay then. All right, cool. That's all I wanted.
Any other questions? Okay, so I'm going to stop this video and then bring in the next piece. Oops, I need to stop share.